So we will use today some real data set which I have downloaded from the external website. And the dataset is a one is the hard dataset, hard disease dataset, and another one is stock market prediction dataset. So I will means apply two datasets because one dataset is for classification, another one is for regression. Sorry, and let me first. Is my screen visible? So I am going to open two generative AI websites, ChatGPT and DeepSeek, both. Okay. So now let's go for the VS Studio VS Code. And today I will use, let me first show you the dataset here. First dataset is the stock data, and read the dataset first. What are the features and what is the which variable is outcome and other things are there. So let me first introduce the dataset. This is the dataset, and you can see the features. Okay, let's see the features here. First feature is a date. Second one is company, then sector, open, high, low, close. This is the candlestick dataset. Okay, if you know what candlestick means, okay, it is a candlestick is a means a pattern. It's a pattern which is basically used in a stock market chart. Okay, in every time frame, let us suppose it may be 5 minutes or 1 minutes or half an hour, whatever the time frame you choose. In between that time frame, what is the movement, the price movement of a stock? It is generally described by the candlestick. So a candlestick, I'm not going to discuss what candlestick is. Basically, these are the data: open, high, low, close, volume, market cap, P ratio, okay, dividend yield, volatility, sentiment score, and trend. These are the different features here. And first you have to decide that which feature or which features you want as a um, target variable, means which one you want to predict. Okay, so here let us suppose that volatility, okay, is one of the means prediction here. Volatility, see, volatility is one of the predict means I am using this volatility. Let me copy and paste it at the end. Yes. So let me use that volatility as a dependent, and all the rest of the other things as an independent variable. Okay, so now here you can do two things. First of all, you can use all the names here. Now suppose that you can see this date. Okay, since it's a data, is it a time series data or not? You need to first analyze it. Okay, So look at this, it is 1 1 2012, 2 1 2022, sorry 2022, 3 1 22. Okay, so this data is basically each and every day data. Okay, and how many data sets are there? Let me see. 1001 dataset means 1000 datasets are there up to 26 9 2024, and this is a time series data. Why it is time series data? Because each and every, look at this, the equal time frame is there. Okay, so 1 1 22, the next day, next day, so each and every day this data is taken, everyday data. Okay, but company names are different here, you can see. So these data, you can see that 1 1 2022, the Uber company data sets are taken, but 2 1 2022, another one company data sets are taken. Okay, so this may maybe a little bit confusion here. So, okay, maybe the direct means the trend may not be that much accurate what you want. If each and every data set, since each and every day these particular things, all data are taken, so it should be taken as only a single company, not the other companies. Okay, otherwise it doesn't mean, the meaning will be not that much clear. Okay, however, since we have downloaded the dataset from an external website, so we can't do anything here, because as it is they are providing, so we need to uh, do accordingly. So one thing we can do here, date, we may drop the date, since different companies are taken here. Okay, so we may drop the date. Now if you look at the sector, it is a categorical data: technology, technology, automotive, finance, okay, aerospace. So these are different categories are there. So sector is a categorical data. Company, I can see, yes, same company are repeated, but the name of the companies are too large. Means many companies are there. Some companies are repeated. So if I consider company as categorical, there are too many category will be there. Okay, generally what we can do, if categories are less than 10 or equal to 10, then we can consider company as categorical. But the category is more than 10, 11 or 12 or more than that, then you can consider it as a continuous data. Okay, so however here we can see that many companies are there, so it may be better to consider as continuous data set. But sector, limited categories are there. Technology is one of the categories. Automotive is another one category. Finance is also. So here you can see not more than 10 category you can find here. So that is why sector may be considered as a category. Now open high, you can see these are the, clearly it is visible as continuous data. Trend, bearish, stable, bullish, these trends are there. So generally trend, there are three types of trends is observed in the market. So bearish, bullish, and sideways or stable. Okay, so only three categories will be there. So trend, of course, it is a categorical, but volatility and all other are others are continuous data set. Okay, so we have studied the dataset first, and now it depends on you that which one you should predict. What is your prediction variable? That is target variable. So here we suppose that volatility is the target, and other one, yes, let me drop something. Date, company, date, you can drop it. Company, yes, company you can accept it. So let me consider all this as categorical, sorry, means independent, and volatility dependent, and target variable. We need to predict what volatility is. Okay, so let me use this data set, and um now first of all, yes, um, what is the problem we need to first identify? Is it a categorical, sorry, regression problem or classification problem? So we can see that our target variable, it is the continuous data. So of course it is a regression. Now what kind of regression we can use here? You can see here there are too many variables are there. We can use, we have to, if you are going for the linear regression, then we have to use the multilinear regression here. Okay, but the data set, look at the data set. it looks like too many data sets are there. Okay, and also there are many things. First you need to analyze whether this independent data, okay, they are having whether they are having any auto correlation or not. Okay, and to do that we need to check the means correlation coefficient between each and every independent variables. Okay, so let me go for the ChatGPT first, and I asked ChatGPT to generate regression problem. Okay, let me intro. I am going to generate the program for not only the linear regression, for decision tree also, for random forest also. Okay, I already have discussed yesterday that decision tree is one of the method, AI method, sorry, ML method, and along with the decision tree, random forest is an updated version of it, where the decision tree itself is splitted into many trees, and we need to go for each means check the values of each and every tree, means decision of the each and every tree, and we need to according to means the combined decisions. Okay, we need to check that which decisions is the maximum. Based on that, we need to find out the our decision. So decision tree algorithm, random forest algorithms, and the linear regression. All these three algorithms we will apply today, and then we check that which one gives us the best result or better result. Okay. Also, one thing, yesterday I have shown you that decision tree for classification problem. Today I will show you decision tree as regression problem. Okay. So let me go to the chat GPT, and first of all, here I am, since dataset is mine. Okay, so I will not provide the means the dataset is not generated by the GPT. So that is why your prompt will be accordingly. Means uh, you can't say here that perform the linear regression or this with the generated dataset. No. Okay, you have to change your prompt like this. Okay, code for an Excel dataset, code for an Excel dataset uh, with features. Okay, now all features you may mention here. If you want that you want ChatGPT to generate the entire program for you, then you have to write all the features here. Okay, so what are the features? You can go to the means here in Excel. Okay, and let us suppose I am not going to give all the features here. Let us suppose that I am using volume, market cap. Okay, volume, market cap, P ratio, dividend, sentiment, and trend. These are the features I am using, not more than that. Control C and just and Control V like this. Okay, okay, let me close this one. So features, volume. You can just put a comma down now. Market cap, sorry, P ratio, dividend yield, comma, sentiment score. Okay, and trend. Okay, let me, yes, volatility is our target, trend, and target volatility. So let me check the spelling means. Okay, why I have copied and pasted here? Because you see here, if you are writing manually, first of all, that may take time. Second of all, the spellings. volume, if you want to generate your code, entire code from ChatGPT, then you need to use the proper spelling of each and every feature name. Here you can see the volatility, volume, market cap, volume V is capital, market cap, market M is capital, then underscore, then cap, and cap C is capital. So each and every spelling should be as it is, which is mentioned here in the Excel file. So that is why better to copy the entire thing and paste there. Okay. So what I have done here. So code for an Excel dataset with features this and target this. Okay, features this, let us and target this. Okay, with linear regression, uh, linear regression and decision tree and random forest regressor. Okay, you must mention regressor because ChatGPT doesn't know. You just have written the feature names, but the GPT doesn't know that what kind of feature it is, whether it is classification problem or is it a regression problem. So you must mention that your problem is a regression problem. Okay, so that is why if it says that it is regressor, then all the things regressor, the regressor function and classification function are different in Python. Okay, you need to use different functions for that. So that is why you need to mention that. Also, another thing, you also need to mention that which variable here is categorical. You see, if you see the data set, one of the trend is categorical, whereas volume, market cap, P ratio, dividend, sentiment score, everything is continuous, but trend is categorical. So let me introduce here trend as a, I need to mention here. Okay, score trend in bracket, you can use that categorical. Okay, now yeah, now it is already it's done. Okay, models, three models, everything. Now model evaluator, every of model is evaluator function is there. Yes, no, it is yes. So items, everything, test. Yeah, it's done. So let me now copy and paste it in my VS code. Clear the screen. Okay, let me see first what it generates. Okay, first of all, I need to change this. Okay, pd.read excel your dataset dot xlsx. First of all, you need to change your dataset, means your path. So I am going to the folder where I have downloaded the data. Here, the data is downloaded. First, let me check that whether it is um, Excel or CSV. Let me check the property first. Yeah, look at this. The file is CSV file. it is not Excel file. Okay, so let me first, so this file is CSV, not Excel. So if I copy the path, so first of all, let me copy the path and I go to the VS Code. So, and R, I already told you why R. Now, problem is, since it is CSV, I can't use here read Excel. I have to use here read CSV. Okay, read CSV. So now look at this. What is, so volatility is dropped here. Okay, so why volatility is dropped here? Because you can see separate features and target. I am separating the features and target. Okay, first of all, DF is having the entire data set. Okay, so except this DF, okay, so DF is having entire data set, and with this DF, I'm just dropping the volatility, and the volatility is added in another variable Y. Okay, so one categorical feature is there. Trend is the categorical feature, I already told you. Now I need to transform this trend because it is categorical. Okay, and all other numeric features are this, which I need to use here. Okay, now preprocessor trend is a categorical, so I need to process it. I already told you that you have to encode this. Okay, so here the encoder, it is used as one hot encoder. Okay, now the later other things are already given here: linear regression, descent tree, and random forest. The three functions I need to use here. Okay, so I have created the, means not me, GPT has created a set. Okay, this set is having three different functions. Okay, and another one to train and test. Okay, because we need to split the train, test, everything. Okay, so here 20% is for testing. Okay, it means that 200 data, the total data set is 1000. So 200 data set is for testing, and 800 data set we kept for training. Okay, and what are the metrics we are going to visualize here? R square value and MAE. Okay, these two are the matrices we are going to visualize here. So let me run this code. Let me check whether it is running or not. Okay, there are some error it is giving. Okay, could not convert string to float. Yeah, what problem is this? Look at this, 31 2022. However, I have used here, means I have used the entire data set. Okay, but entire data set, it is having much more columns. Okay, if any error is occurred, then how to understand that what kind of error is this and why your program is not running? Look at this, 31 2022. Okay, could not convert string to float. So 31 2022, it is simply the date. And which one is the date? The first column is the date column. Okay, now we didn't drop the date column here. Understood? So we didn't drop it. So date column is there. It is also reading the date column. So that is the problem here. Okay, we are means date column is there. So that is why it is not going to, because it is not converted to any kind of encoder. So what we need to do, we need to drop the date column here. Okay, otherwise it will giving you again the error. Okay, another things you can also do here, the preprocessor here, one hot encoder is used. Okay, instead of one hot encoder, there is another encoder which is used previously, that is um, level encoder. That encoder also can be used here. So in that cases, you need to, okay, let me first run this code with dropping the other columns. So let us drop Okay, go to the GPT again. Okay, so what we do, we will uh, first write down use label encoder, modify, sorry, modify the code using label encoder and only use the mentioned features. Yes, I think this code will run now. Let me copy and paste there. Okay, now this code is much more easier code than before. So now let me copy the path. Okay, here what we have done, features only we are using these features and not anything else. Target, we are only using the target as volatility. Okay, now we are creating a variable x which only use these features and nothing else, and y which is only using the target, that is this one, volatility. We are not considering all the other features, that is date and whatever the other columns which are already mentioned in the excel file or csv file. Okay, yes, first of all csv, so read csv. Okay, now we used here label encoder on trend, and we transformed label encoder, that is trend, with the numberings, that is numeric data. And then we split the data set using the test, training and testing data. And then we used the three algorithms. Okay, and only r square value and MAE, these two things will be um, printed here. So let me check that whether this is running or not. Yes, now you can see this completely looks good and runs well. Let me use there. Let me clear the screen. Yes. So it's now looks fine and it runs very clearly. So you can see here uh, the linear regression. All the three data sets are there. Sorry, three results are there. In linear regression, what is the R square value? 0.003. MAE value 0.011. Decision tree R square is minus. Okay, it means that model is underfitting model. Okay, MAE is 0.012. Random forest, again it is minus, and 0.011. So you can see no model is fits better here. Okay, only the linear regression, it somehow it fits, means at least the r square is positive. In the other cases, decision tree and random forest, okay, everything is giving you the negative value. So it means that decision tree and random forest, we should not means consider here for this data set only, decision tree and random forest, only linear regression gives you somehow it is better, but also linear regression is also not better. So how can you modify this result? Okay, the modification is can be done by using the higher means methods, like means modified method, like xg boost, that is extreme gradient boost, and cat boost. Okay, also using the ensemble method. Okay, ensemble is I'm not going to say this one what ensemble is. Okay, so this is how you can see that means that this data fits or not. So another thing also we need to check. Okay, what kind of checking is there? Let me first give you um, these features, how correlation is there in between these features. That thing is also should be considered. Okay, so let me go to the code again, and now I'm going to give here that add correlation matrix and heat map. No, correlation heat map is heat map with above. Okay, now correlation heat map. Okay, I have done a small mistake. Add correlation heat map with the above. Okay, it creates the correlation heat map for all the variables, but I wanted only for the features. Okay, let's see what happens here only, because that also looks good. Okay, I forgot to change the data set. Okay, again, yes. So as you see here, okay, so this data set, the volatility also, each and every data set doesn't have any relation in between them. Okay, if you see the volatility also, so volatility also doesn't have the relation with any one of the variables. That is why the correlation coefficient between, you can see the volume and volatility only minus 0.02. Market cap volatility is also very low. Okay, everything is blue. Blue means it is very low, either means in very near equal to zero. So volatility is our target variable, and with our target variable, no other variable is there which is having any relation. So that is why our model, it is getting too much weak model we are finding here. Okay, so in this case, what we can do, let me in these cases, how to modify your model. First of all, there are many methods are there. This is a very less time, I can't means give you that much of explanation how to increase the accuracy of your model. Okay, there are many outliers. What kind of outliers are there? We need to first select. Means and that outliers we can identify this by using that uh, histogram. Okay, so you need to first check the histogram or each and every variables here, whether they are outlier or not. Also, you can check it by using a scatter plot. Okay, whether how many outliers are there. Okay, also another thing we can do this, we can do it, we can normalize that. Okay, we can normalize each and every variable here. Okay, by using the standard normal formula. Okay, many methods are there. We can increase the accuracy. Okay, so that are not our means in this lecture with this limited time. I can't explain all of these things. Okay, so this is the basically this is how you can generate the code through ChatGPT and you can easily do everything. Yes, of course, if any error occurs, you need to understand that why that error occurs. Also, if you don't understand, also you can just copy and paste that error into the ChatGPT. The GPT will give you yes that this is the error. You can modify, or the modified code can also be generated by the GPT. But sometimes what happens, for any kind of misinformation, GPT can also not generate, because GPT it is run with your prompt only. Okay, so if your prompt is having any misinformation, that is here only you can see that I didn't or I have only said that volume, market cap, these are the features, but it didn't say the GPT that there are other features which I means omitted totally. Okay, so that is why the GPT has created a code. GPT, what the GPT understands that only these are the features are there. There is no other features. So that is why GPT has generated the code accordingly. But if you run that code, of course, that it will give you the error, because we are considering the entire Excel file there. And entire Excel file, it is having other features other than these features which we are using here only. Okay, so that is why you need to uh, write the proper prompt. Okay, so there is these are the features, these features we are omitting, these features we are adding. Either use the proper prompt, or if you use the improper prompt also, after generating the code, if any error occurs, you need to understand why that error occurs and how you can remove that error. Is here, since the date is visible, okay, I can easily understand that the date column it is taking, and without encoding the date, because that was that date, it is not means encoded with a numeric value. Okay, and the strings cannot be we cannot perform any kind of this analysis, AI ML or statistical analysis through any string. So that is why without encoding them we can't proceed. Okay, so these are the things, little things you need to understand. Okay, and this can be done by practicing and practicing with this generative AI. Okay, means with this coding, many errors you can find in initial stages. Okay, now you need to means understand day by day that how you can remove that error, how you can understand that why that error occurs. Maybe you are not proficient with the coding, but coding GPT can do each and every coding. Yes, of course, you need to identify the error. Okay, and why the coding, or if any line is there, you need to also understand that why this line is written. Okay, that things you should understand. Okay, now I'm going to give you the another data set for classification. Okay, the second data set is this one, heart data set. That is prediction of heart disease. Yeah. So as we see, Age is here, you can see age is a continuous. Sex, male, female, it is categorical. Chest pain, ATA. NAP, ATA, yes, this is also categorical. This is continuous. Cholesterol, continuous. Fasting, BS, 0 or 1, this is categorical but already encoded with numbers. Okay. Resting ECG, also categorical. Sorry. Exercise, also categorical. Old peak, categorical but encoded already. ST slope, half, flat, flat, yes, also categorical but yes, not encoded. Heart disease, 0 1, that is yes or no. This is categorical but encoded with 0 and 1. Okay, so in which features the encoding is needed? Sex, encoding is needed. Chest pain, encoding is needed. Uh, Resting ECG, encoding needed. Exercise, encoding needed. And ST slope, encoding needed. Okay, so these are the things where encodings are needed, and rest of the other things, numeric values are there or continuous values, so nothing is required there. Okay, so now how encode we need to encode it. So here you can use a prompt in different way. Okay, that you know that yes, if you are totally layman, then better to uh, do things like this. Just simply first go to the snipping tool. Okay, let me use the first thing. If you know programming somehow, let us suppose, okay, you know programming, and in a certain level, okay, and you see that yes, there are some means these are the encodings are already needed. Okay, I know that encodings are needed here because the data is categorical but not encoded with any numeric value. So I know that encodings are needed. Okay, and also I know that yes, I am to predict the heart disease, yes or no. So in this case, heart disease, yes, no is we can. So this is a categorical feature, and heart disease is a target. So it means that it is a classification problem. So classification with encoding. Okay, and how many columns are there, and how many target columns, and how many means independent columns are there, I know already. So in that case, I can go to the GPT and I will say that yes, if I am not a layman, so I can say like this: code for, okay, let me first see whether it is CSV or this is also CSV. Okay, CSV dataset. Okay, dataset with how many feature column is there? One, two, 1 2 3 4 5 6 7 8 9 10 11. 11 features. Okay, and within bracket you can write that um, some of them are categorical but not uncoded, encoded. So 1 2 3 4 5 5 are categorical. 5 categorical non encoded. Okay, and one target binary. Okay, so code for CSV dataset with 11 features, 5 categorical non encoded, and one target binary. Okay, with uh, logistic regression, um, random forest decision tree, and random forest. Okay, let's see what it generates. Okay, yes, now see, it generates everything. Okay, now if I copy and paste it, we use another new file. Okay, first of all, now how you can modify here? First of all, you need to change your data, file path. I'm changing my file path, and then all the category names you need to just replace here. So I already told you all categories are there. So now let me go to here. So what are the categories we need here? Our needed first we categorical features which are non-encoded, means numeric features. Okay, first categorical features which are non-encoded. Okay, so let me go to the Excel file now. So non-encoded category features are sex, then chest pain, then here this one, exercise, st slope, 1 2 3 4 5. Yes, let's copy and paste it here. Okay, now what you do, you just need to use, okay, 1 2 3 4. Okay, I think I've done something wrong. Okay, first one is 6, so let me use this one only one by one. Okay, so just you can double click it and you can replace it like this. Second one is chest pen type. Okay, chest pen type. Third one is cholesterol resting ECG. Fourth one is this one, exercise. And the last one uh, is ST slope. Done. Similarly, the numeric features also we need to paste here, copy and paste. Numeric features also, 5 numeric features are there. So numeric features are age. Okay, age. Second numeric feature is resting BP. Third numeric feature is cholesterol. Fourth one is fasting. Fifth one is uh, max heart rate. And the last one is cold peak. Yeah. And our target, what is our target? Our target is here, heart disease is the target. Okay, so let me copy and paste here. Heart disease is our target. Okay, I think heart disease. That's all. Now everything is done. I think it can run now very easily. Okay, so yes, rest of the things are okay. Yes, it's generated now. Now let's see the score. You can see all the scores are written here. First one is logistic regression. What is the accuracy? Very high accuracy, 0.842. F1 score also very fine. Okay, and here in decision tree accuracy a little bit less. Okay, so in classification report, logistic regression still it is high. Third one, random forest, 89, 0.89. So 0.89, 0.79, 0.84. Yes, so who wins? Random forest wins the race. So random forest will give you the highest accuracy. Okay, so similar in the similar way now, you can also see the means the confusion matrix for each and every cases. Okay, let me ask the chat GPT that add confusion matrix also. Add confusion matrix for each uh, algorithms, for each method. Okay, I will just copy and paste the last one. I'm not going to change the entire program here. Just the necessary part I'm going to add. Okay, now here you can see, I think PLT and SNS is not here. So it means that I need to add matplotlib. Okay, import first into, okay, and matplotlib. Yes, now I think it will run. Yeah. So it means that means anything PLT, SNS. Okay, since it is underlined, it means that underline means some library is missing. I already explained this one. So now PLT, you can say CM. Also, there is another thing. CM is another thing which is not recognized by the program. So let me check that what it is. Yes. So this one we need to add. Okay, so you understand. So you need to understand that why anything is okay. You can see only up to F1 score it is added, but we didn't add the CM here. Confusion matrix also it is giving as different. So confusion matrix, I think it was not imported. Yes, it is not also imported. So you need to import here confusion matrix. Yeah. Now I think it will add. Yes. Now classification report. Nothing is there. Let me check now. Yes, the confusion matrix for logistic regression. Okay, so confusion matrix for logistic regression is this one. So true positive, okay, true positive, true prediction, predicted true, and is true one, true zero. Okay, false is not written. Okay, 1000. Okay, false negative x68. That is also okay. So true positive is also very high. Okay, next one 65, it is not written. 68. Yes, is there the matrix written here? No, the matrix is not written. However, we can see that the random forest giving you the best value here. Okay, so this is how you can generate the code, okay, for each and every kind of data set. And also there are many other metrics are also there. AUC, ROC is also there. And in regression there is scatter plot and the predicted values and the original value and the predicted value plot is also there. Okay, so that plots I am not going to show now because I will show if possible next day. Today, tomorrow is the last class. Okay, so I will the rest of the part, that is some AUC, ROC curve, AUC, and uh, the predicted and actual scatter plot for regression problem, I will uh, means share you tomorrow. Okay, so this is all for today. If anybody has any kind of doubt, then please ask the question. I'm open to ask.
So first of all, thank you so much, sir. So audience and participants, if you have any doubt, please write down in the chat box. And can you just, I have one small question from my side. As you have showing this 68 and 5 and 9, can you just tell me that what that signifies and all?
Sorry.
When we are comparing the data, right, we are getting
Yes.
one side like 68, then 9, some values are coming. Can you
That
just,
is your talking about the confusion matrix.
yes, a confusion matrix.
I already explained what confusion matrix is in the last class. Okay. 68 or false positive, false positive, true negative, false negative. These are the four cases here.
Yes.
Okay, so these are the cases. Let me explain this one. This is the confusion matrix which I already have means explained last class. Okay, what the values, which value defines which one. Okay, let us suppose I am a very simple example. If I say a confusion matrix, it is like this. Let me wait. 0 1 0 1. This is predicted. This is original. Is original 0 1. So if the dataset is like this, suppose x1, x2, x3, these are the features and y is the target. Okay, and now suppose uh, 2 3 1, it is 0, 1 1 2, it is 1, 2 2 1, it is 1, 3 3 3, 0, 1 1 2, 0, and so on. Okay, if I talk about only this data set, okay, I need to check that. Now suppose I have done a model. Okay, I have created a model, and our model predicts the value y new values. Okay, if I pass the same values, what is the first value? 2 3 1 is the first value. So if I pass the same value to our model gives the prediction as suppose 0. If I pass the second value 1 1 2, our model predicts suppose 1. Third value I am passing through my model, it gives us again 1. Fourth value I am passing to my model, it is giving 1. Fifth value if I pass, it is suppose 0. Sixth value, it is suppose 0. Seventh value 0. This value 1. Okay, now here I need to construct this matrix by only, okay, by evaluating y and y new. So y is the original value, this is our original, and this is the predicted, right? Now the first column, what is the index of this particular cell? This index is, you can see, 0 0. So this index is 0 0 index. Okay, 0 0 index means how many original 0 values are there and how many 0 values are predicted rightly. Okay, so you can see this is predicted rightly 0 0. This is predicted rightly 0 0. This is predicted rightly 0 0. Okay, any other values are 0 0 values are
No.
there? No values are 0 0. So how many times? 1
Three.
2 3. So I will write here 3.
Okay.
Okay, now second index, it is 0 1 index, right? 0 and 1. So second index, it is 0 1 index. So the original value is 0 and predicted value is 1. How many times it
We
occurs?
have only
So
one.
original value 0 one time, this is no other time, so it is 1 only. Third one, what is the index of this? 1 0 index, right?
But
1 0.
then became one.
1 0, let me check that. 1 0, yes, this is 1 0. Is there any other 1 0?
No.
No. So 1. And now rest of the part. Rest of the part, of course, the other values are rest of the part.
Yes.
Okay, means 1 1. This index is 1 1. How many values? This is 1 1 1 1 1 1. Okay, so 1 2 3. This is called confusion matrix. Now, confusion matrix shows you that how many values you can correctly predict it. Okay, so 0 0 means correct prediction, 1 1 means correct prediction. But 0 1 and 1 1, sorry, 1 0, it means your prediction is wrong. Okay, so it means that 0 1 and 1 0, there should be less amount of number, less number will be there, and 0 0 and 1 1, there should be highest number. Then only you can say your model predicts properly. Okay, means your model accuracy would be better in that cases. Understood? So
Good.
if these values are high but these values are low, it means that your model is not a good model. Now are you getting my point?
Yes, sir. So that first of all, thank you for clarifying this. And we don't have any further question in the chat box. And feedback link is also active. So requesting all the participants to kindly fill up the feedback form before we leave the session, and make sure of that tomorrow we have a last session, not today. So make yourself available, because tomorrow is a very special class, right? So thank you everyone, thank you for your time, and hope you are understanding and going to utilize this concept in your research work or in the other activities. Thank you so much, thank you everyone, and have a good day. Good night. Thank you so much, sir, for your time.
Thank you very much.